Well, hello and welcome back to Risk Management. Today we talk about illusions. In the past few classes, we've been trying to distinguish between objective perception, knowing that something actually exists out there that we can sense, and illusions. What we're going to do in the next few classes is kind of a fun little diversion, which is looking at various illusions, and then after that, trying to see how people control for those illusions to get the essence out of what is actually going on out there. So let's get started. To refresh ourselves why we're on this exercise about illusions, remember this is a class about risk, and we gave a definition of risk way back at the beginning that it's the probability that a stimulus causes a harmful effect. Well, implicit in that definition means we have to know that there's a stimulus, we have to know that stimulus causes, and specifically we have to know that it causes a harmful effect. In order to do that, we have to know about causation. We gave a definition earlier of causation, a change in a stimulus that determines a directional change in an effect. You'll see this definition again and again. If I break it out into sentence fragments, what you'll see is we're talking really about the first and the last fragments of that sentence, a change in a stimulus and a change in an effect. Later in this class, we'll talk about determination and directionality, two other important concepts when it comes to causation. But right now we're talking about phenomena, the stimulus and the effect. How do we know those exist? Another word for a stimulus or effect is a relatum, or plural in Latin, relata. These are the phenomena that we gauge out in life and make sure that we actually know what's going on, that we observe things to occur. So with that in mind, let's turn to illusions and see how illusions can distort our perception of phenomena and how we have to try to overcome those many illusions that exist. This quote is one I like in particular. It says, "There are numberless illusions which must be taken into account. All are of interest, many can be used, and some must be suppressed." That's true in risk management too. Illusions go on all the time, and to get to the true risks, we need to suppress the illusions. Here's an example of an illusion. Take a look for a moment. Those diagonal lines are parallel. This is a classic illusion from the 1860s. What happens is your eye distorts the angles because of the alternating parallel or perpendicular lines, I should say, to the parallel lines. Here's another one from the 1860s when people started getting interested in illusions. This one's called the Poggendorf illusion from 1861. Which one lines up with C, A, or B as a line? Do you have the answer? If you don't know, get a ruler out on your screen and try doing it yourself. A good number of people get this one wrong. In fact, people who were studying this back in the 1960s, Hubel and Wiesel, found that in cats got this wrong too, and they actually found the parts of the brain that when looking at this, it turns out that there are specific cells that control this visual image in the brain. Some cells actually distort this image because they oversuppress certain angles, and others, in other words, have a lateral inhibition on it, causing an overestimate of certain types of illusion. So what we discovered in the 1960s was this is not something going on out there somewhere or a visual problem. It's actually a brain registration issue, that the brain is misregistering the actual dimensions of the lines because of specific cells in the brain, and they could isolate those cells. The point that this was going on was also indicated by the fact that even if you remove the parallel lines, you still have these illusions that occur. Take a look. When you remove the acute angles on the left, you still have a misperception that these lines don't somehow line up. And when you remove the lines that are parallel and have obtuse angles on the right, it still looks like the arrows aren't pointing at each other to many people. This shows it's not that the lines are skewing perception, but that it's the angles, in fact, that are distorted by people's visions. Here's another one that's fun. Take a look at this one for a moment. Here's a triangle on top that has various block components of it. The grid lines behind it indicate the actual area of the triangle. There's 4 pieces, 1 red, 2 green, 1 yellow. Now if you reassemble these pieces, not changing the dimensions of any of the fragments of that large triangle, but simply shifting them around, you can create a scenario where, using the same apparent area as in the first grid, you can create a circumstance in which there's an extra open square. How does that happen? Think about it yourself. Maybe you chat about that on the chat boards. That would be a fun one to talk about today. I'll give you another moment to look it through. You can freeze the tape if you want and look longer, but let's move on. Here's one that I like, called the moon illusion. Have you ever noticed on a nice night that when the moon's low on the horizon, sometimes it looks really big, and then when it's higher in the sky, it might look distant? Did the moon suddenly move very far away from the Earth or get very close when it's low on the horizon? Or is there a distortion going on that makes this large object look larger or smaller based on very relative small differences in the angle to the Earth? Here's one called the herring illusion, also from the 1860s. Those 2 lines that are the major gray parallel lateral lines are in fact parallel and not bending. Here's one called the Hermann grid illusion from the 1870s. If you look at the cortexes, the vertices between all of the black squares where the white lines cross each other, you should see small gray reflections in each of those. Do you see them? Let your eye sort of drift naturally across the middle, scanning left to right, looking at those white intersections. You should see little gray dots forming between each of those vertices. Okay, let's try another one now. Here's the cafe wall illusion from 1979. I know it doesn't look it, but those gray lines in between all of the black stacked boxes are in fact parallel. Strange, isn't it? If you don't believe me, check it out yourself. Get a ruler, put it to your screen, you'll see. Here's another one. All the lines are straight in this particular example. If you don't believe the lines are straight, again, get a ruler. You'll see it is. Here's one called the Weechee illusion. Does it look like that circle in the middle is floating over a background? Here's one called the Ebbinghaus size illusion. In the center of each of these circles is a ball. The ball on the left is the same size in area as the ball on the right in the center. Our comparative judgment is skewed by the fact that one ball is surrounded by large balls, the other by small. Here's one that's interesting. These are all the same sized blocks. Now you'll insist they're not, but if you got out a ruler and measured them on your screen, you'd see they're the same length, width, and height. This one will be important to talk about again in a minute, because sometimes certain people with certain brain injuries do perceive these to be the same height, width, and length, whereas most of you, I suspect, do not. Can you think of why the difference exists? Sometimes it turns out that people can actually get a better sense of dimension of various objects, not just by using their sight, but also by having tactile usage during the same time. If you touch a box and feel its width, you have a better chance of guessing the length of that box if the length of the box is variable and changes simply by touching the width. Now that seems strange. By touching the dimensions of one side of the box, when the other side of the box changes in length, why is it that touching one dimension gives us additional sensory input to our vision that makes it easier for us to determine other dimensions than the one we're touching? And yet that is the case. Very interesting experiment done by Gunnell and Goodale in 2004. Here's another one that's interesting. Take a look at this. The area of the outside ring that is shaded in gray is the exact same area as the 3 internal rings that are shaded gray. Do you believe it? Well, if it doesn't make sense to you when you're looking at it, take a look at the math below. Pi r squared is the area of any circle, and let's assume that the distance between rings is 1. Then in the outer ring, the amount would be the total area subtracting the internal circle, and the internal circle would be 3 squared pi. So that's 9 pi for the inner circle. The outer circle minus the inner circle is likewise 9 pi. Crazy, right? Here's another one. Look at the center dots in each of these squares. They're actually all the same shade. Background context matters in determining how light or dark something is. When we judge it, we look to the background to give us context. And when we have a light background, something might look darker, whereas if we have a dark background, something might look lighter. Here's one that's interesting. There's numbers in each of these circles in the middle. Can you read them? Well, if you can't, don't feel bad. About 10% of the population cannot read some of the numbers in these examples. If you're curious, starting with the top left row going to the right, it says 25, 29, 6, and then from left to right in the bottom row, 45, 56, 8. If you didn't get all of those, it might be that you're colorblind. About 10% of the population is, at some various level. Now, here's what we could do to have things get even a little more fun. A lot of the things I just showed you are known illusions, where people's senses, specifically their sight, but sometimes also involving other senses like touch, taste, smell, and so forth, can be manipulated in intentional ways. So here, for example, Kitaoka and Ashida, 2 Japanese scientists, did a very brilliant little study. They wrote down a series of known distortions that people's vision have. In other words, they studied illusions and found why illusions are effective in tricking human beings, particularly visual illusions. And they came up with 5 specific examples. You can read through these, but it's things like peripheral vision creates distortionary illusions. Or number 5, we all have involuntary eye movements. There's a slight flicker in our eyes that's unavoidable, and therefore eyes can have slight distortions in terms of what they see. If things have, for example, number 4, fragmented or curved edges, that tends to distort our understanding of perspective and dimension. So understanding these principles about why humans are susceptible to illusion, they then created a scientific, designed, calculated illusion. And here it is. Does it look like things are swirling now? It probably should. And yet this is a static painting. Nothing's happening here at all. There's no movement on the computer animation. This is a picture of it's fixed. Then sometimes there's interpretive problems for humans, looking at portrayals of things or interpreting what data it is they're seeing. What is this, for example? This is Wittgenstein's famous painting from his philosophy work. Do you see a duck? Do you see a rabbit? Or do you see both? Here's another example. Who sees an old woman with a bump on her nose? Or do you see a young woman looking away? How many legs does this pachyderm have? Look again. On first glance, the temptation might be to say 4, the normal number. That's because normally when you look at elephants, on first glance, that's how many they have. This one, however, is an artistic trick. Here's an impossible triangle. Do you see why it's impossible? If you don't, try constructing this out of Tinker Toys for yourself, or Legos. I don't think you can do it. For those of you who are aspiring architects out there, try building this structure somewhere in your backyard. My guess is it won't pass the zoning department's permit stage. Okay, that's a bunch of fun illusions for today. We're going to carry on this discussion in a number of lectures, and I'll show you some additional illusions, but we'll also start to gain some insights into why these illusions are occurring. What's going on in the brain, and what do we understand about human perception that might help us to dispel illusions so that we don't make mistakes about them. Again, we're studying phenomena right now, and the reason that we're doing this is phenomena are important to get right. If we misrecord what exactly it is that we're sensing, then it's saying that one thing causes something else when in fact the one thing never existed at all is misstating the actual risk. Okay, I'll see you on the chat boards, and I'll be eager to see what you think about the different illusions you saw today. Bye for now.